Hey everybody, as promised, I finally got to a position in the shop to where I could do a full review, or at least a 90% review of that Vevor MX S1170 metal lathe. I purchased that lathe for $1,350, I believe it was, and I did so with the sole intention of doing nothing, just for a review for you guys, because I was getting so many questions and there's just no information really out there on that machine. And we're going to end up going into the shop area and I'll give you a rundown of it. But first impressions, when it arrived, it did arrive in a crated box, bolted to the bottom, very secure. I was quite impressed with that. And it took three of us to pick it up and put it on the bench. And then after unboxing and getting it set up to plug in for the first time, I plugged it in and I had no power. So, first red flag. But later I realized, after opening the back of the unit, that a couple of the wires were loose from the contacts, and I chalked that up to shipping vibration. I can't necessarily blame Vevor for that part of it. So I put the wires back on the clips, pushed them back in, and it turned on fine. And then I began to give it a deep clean, because it was very hard to move the cross slide, the hand wheels, and the auto feed was tight. It had slop in it and play. You slide it back and forth. So I had to adjust that. And the compound cross slide, it was very tight and it needed adjusting as well. But there was a lot of packing grease on it, which was causing a lot of this drag and resistance. So, even then, I fully expected to have some adjustments and tweaking and modification to do to the machine, to some degree anyway. And I finally got it to a position to where, believe it or not, it's running a total run out right now at about, I'd say, 6 inches. It is less than a thousandth of an inch. For $1,350, I can't ask for more than that. I mean, that's pretty good. Very accurate. Now, I did take it a step farther. I machined brass and wood and steel and stuff like that, giving it a real true solid test. And it did machine those materials rather well. The best finish, of course, being on the brass. Then I moved a step farther and I decided, okay, well, let's see how it does with coring. So what I did is I got a quick change tool post. I forget whether it's an AXA or an OXA, but anyway, I got a quick change tool post for it. That was a quick swap out adaptation, worked pretty good. And one of the quick change tool posts that go on the quick change was for a boring bar. It's a 1/2 inch hole diameter. So I used my side air gun drill that I typically use for coring my wood, stuff like that. And coincidentally, it slipped right in there. So I put the gun drill into that tool post, and then I put that tool post back on the quick change. And now I have the gun drill set up at this point. I have the gun drill set up to where I can use the auto feed and it'll travel for me. I no longer have to put it into the headstock. Great idea. I was kind of crossing my fingers, hoping that was going to be a saving grace for me and I could actually put the machine to some use. I cored the first piece of wood. It went straight through. It did a great job. It gave me, like I said, on an 18-inch piece, I quartered 12.5 through and cut off the extra, and measured the distance on the hole on the exiting end, and then I measured the hole on the center on the hole on the entrance end, and they were within 1/1000th of being true dead center. And I was thinking, great, thumbs up, this is going to be great. And so then I tried a little bit harder, denser material. I cataloged, and that time it cored about 6 inches in, and 5, 6, maybe 7 inches in at the most, and then it locked up, it bound. The spindle stopped because the gun drill had gotten locked up inside the catalogs. However, this being a direct drive system, motor that is, the motor was still trying to continuously turn it, and that created an overload as far as it raised the amps, and then that caused it to shut down. And it has internal safeties that, during an overload it'll shut down for a period of time, and you have to unplug it, turn it off, and let everything cool down and reset itself, turn it back on, and you're good to go. In this case, that was not what I was getting. It didn't matter if I let it sit for 10 minutes or an hour or overnight, it was not turning back on. The control board worked, everything was still functional. The only thing that wasn't happening was the spindle was not turning. So in the back of the machine, there's a panel. You take that panel off, it's about 6 inches by 8 inches. Take that panel off the back of the machine, and then you will see where the power supply is, and then you'll see the stepper motor control board, and then you'll see another little black circuit or board, and that is the 110-volt input power regulation. And what that board does, it doesn't just deliver power, it governs the power based on the load being presented. So it can automatically adjust what is providing. And I checked, and remember, the spindle's not moving. So I checked the potentiometer. Potentiometer was fine. And then I checked the main fuse in the back. It was fine. And then I started researching and looking for maybe a reset switch or a reset routine that I could do, to no avail. And then finally I got my magnifying glass out, and I started inspecting each board, looking for black wires, weird smells, stuff like that. And on the power supplying board, the black one, I finally noticed it has, for some very strange reason, it has an integral glass fuse, the same type of fuse that you typically pull out and replace. This one is actually soldered into the board. That one was black. It had blew the fuse. So I took a flathead screwdriver and I crossed over it, creating a bridge where the fuse is, and then I powered it back on. I had a little slight spark, which is okay, and everything lit back up on the board, and I could turn the machine on and it would rotate. So that tells me definitively that I overloaded the circuit and it blew the fuse, so not a big deal. But to me, what was a big deal is the fact that it's an integrated fuse. How do you change it? You don't. So what I did is I just omitted the fuse altogether, and I soldered one wire on one side, another wire on the other side, and I put a interchangeable fuse block in it, so now I can actually change the fuses as they blow. But other than that, let's see, other than that, I think that it's a pretty solid machine for what you're paying for. And for $1,350, at least that's what I paid. It may be more, maybe less now. I do believe that it is a very sufficient machine. It has enough torque to do whatever you want it to do. It did core just fine, which is probably the toughest test I could have given it. a lot of the binding issue and during that coring process, well, a lot of that could have been me. You know, for that machine, I could have been feeding it too fast. I could have had the RPMs up too high. I could have had the gun drill at a slight angle off a parallel. There's a couple things that it could have been, you know, user issues. And but again, you know, with all that set aside, I would say that it's a decent machine, especially for the cost. And now I'm going to go into the shop area and give you a quick example of it cutting some brass, and I'll show you briefly the functionality on the display. The user manual, you may as well just throw it in the trash. It's not going to give you much information at all. But with a little bit of time with the machine, you can figure it out yourself. It's not that hard really, and it is a semi-automatic, which means that you have auto threading, auto feeding. You can set it to go to a certain distance and it'll stop right there. You can actually set it to return back to its zero location, because that portion of it, the auto feed, runs off of a stepper motor, a servo motor actually. So it is partially CNC, and I like that aspect of it. But you can either have it in automatic mode, or you can have it in manual mode and do everything by the hand wheels. Speaking of hand wheels, it was a lot of play or backlash in the hand wheels, all of them actually, and I was able to reduce that backlash to a tolerable, you know, amount. And it has taken me a while to get all that stuff done. Again, I haven't had much time to work on it. I've been so busy in the shop. But nonetheless, let's walk into the shop area and I'll give you a quick rundown of the machine as far as the digital display and the hand wheels and the cross slides and automatic versus engaged, disengaged. And then finally we'll cut a piece of brass and I'll show you the finish quality that it can provide on metal. So let me get over there and I'll be right back. Okay, so here we are in the shop. We're back at the machine. Let me give you a quick overview of the distance and the sheer size, and I'll go down and let you see what everything looks like. We have the main display board, we have the forward, off, and reverse, we have a kill switch, and then again this is the MX S1170, and I did add a rear chuck to this. I got that rear chuck from Chris Hightower with Keysmith lathes, and it went on pretty easily. And then down here you have your potentiometer, and then that is the quick change tool post that I added. Again, I don't remember if that's the AXO or the OXO. Down here you have your typical hand wheel for your Z travel. And you have a cross slide hand wheel that controls the in and out of your cross slide. Up here you have a compound cross slide, but you know, like I said, all of them have play, and the play is I'd say probably 5 to 8 thousandths before it starts to tighten up on that one. This one, yeah, probably 8 thousandths again. And then this one down here, you're probably looking at, well, about 4 thousandths, 3 thousandths. And it's okay, I can deal with that. Here is your lock for your power feed. You disengage it and you can turn it if you want. And then you just re-engage and it locks it in. And of course, you got your chuck, which this is a 5-inch chuck, I believe, with a 1 to 1.5 inch spindle bore. Perfect for cues. The bed on this machine is ground, has ground ways, and has been hardened, which was actually rather impressive. The lead screw for this power feed, well, it had a lot of play in it, back and forth. So, in other words, if I had this engaged, I could still slide this headstock back and forth. It has an adjustment back here, one nut back here, that you can adjust. It's Allen and hex key, and that will allow you to put tension on it to adjust that play, that backlash. So I was able to get rid of that. It has 0 backlash now. And then of course here's your tailstock. Now I did change out this chuck. It came with a 1/2 inch chuck. I put a 5/8 inch chuck on it. It has a Morris 2 taper, and the lever is really easy to adjust. Slide up, slide back, put it wherever you want to, and you just push it to lock it back down. Good to go. Same thing on this. It will go in and out really easily, and you can loosen it up or lock it down with that. And let's see. I'm trying not to cut this video here. Let me show you the assembly that I had and still have for boring and coring. Now, but before I do that, this is a true 39 inches between centers. So you can comfortably get a full-size butt or shaft on this machine. That's a given. So the size is there, not a problem, no limits. But let me put that boring bar, the boring bar on here. So I'll do that by just disengaging this, rolling it back far enough to where I can put it on. Then you just disengage or remove this tool post. And then, remember I'm doing this with one hand, guys. And then you put the boring bar assembly on here. And once you get that in, then you tighten it back down. And now you can see I have the boring bar on there and it's ready to go. And you have your side air, which in my case is up vertically. And now it's attached to the cross feed or the cross slide. So now it has power feed capability. But here again, I'm not going to test that again until I feel comfortable that I have it set up properly, so it's not going to blow into the circuit. But what I will do is put this one back in, and we will do a test cut on some brass for you. Let me get this cranked back down. I'll get it somewhat in position, and then I'll lock it down. It's okay if it's a little far off, okay? And now for power options, give me just a moment. All right, let's see how well you can see this. You raise it up, make sure it's either in forward, there we go, either forward or reverse. If it's in the off position, nothing's gonna happen. So in forward, open this up, which is your kill switch. You just smack it if you get in trouble. Open that up, press power. When you press power, digital display will activate. And you can see there, it starts off when it loads, it's going to give you a feed. And that is when you have it locked and you have it in auto feed. You set the feed length, which basically is how fast per second you want it to run in millimeters. Unfortunately, you do not have the option for inches, but you can do a conversion with a calculator and get the distance. Your position is basically where it's located in relationship to your work product, and you can zero that out by pressing the set button and wherever you want it zero to be. And then notice right here, it has an arrow there. Down below, you can set direction. If you pay attention to the arrow, set direction. Notice it'll flip as you're putting it in the other direction, and that makes it go in that direction. So you can increase the speed by simply pressing the button. Let's go up to, I think the maximum is 0.40 or 0.4 millimeters, and then make sure that you're activated here. And now this should move away from the product, and let's check that. Got to turn it on some, and you can see that it works just fine. and you can reverse it by simply pressing the set direction button again. No need to turn it off. And notice it goes in the other direction. Very tight, very smooth. I am impressed with that. And I'm going to let it get to a certain point, and then I'm going to pause it so we can cut. Right there is fine. Now when you hit pause, or run stop pause over here, it will stop it on a dime. So it's very precise. Now what I want to do is set this up on the tripod so I can have both hands, and you can see it make the first cut. So give me just a minute to get this set up on the tripod, and I'll be right back. Okay, I have it set up on the tripod, which means you're not going to be able to see me on the digital display, but again, I showed you that earlier, and it's pretty self-explanatory. So the mode that I have this in is simple feed mode, and what we're going to do, the main point here, is to make a pass on non-ferrous metal like brass, and to show you what kind of finish you can expect to get. So let me turn the RPM speed up. I'll turn that to about 600 or 800. And turn the speed down some. Then we'll lock it. And let's see what kind of cut we get. Now, I think this is a very good finish, considering. Now I'm taking about, I don't know, 6 thousandths off of this. It's making good quality chips. And you can make it go faster or slower, but depending on how you change that will determine your quality of your finish. Now when I get to the end of this run, I am going to go ahead and push it to go in the other direction. And again, you do not have to turn that off to make that happen. But I'm doing this in the other direction to show you that by putting it in the other direction, it doesn't twist or move the cross slide, so it will maintain the same level of cut in the other direction as well. So we're almost there. But here again, I'm not going to stop the machine. I'm just going to simply press the direction button and make it go in the other direction. Okay. Now press that, and now it's going to go in the other direction. And if you listen close enough, you can hear it barely touching that surface. It's very accurate in the reverse, and it's very accurate in the tolerances that it holds. However, it did take a lot of setting up and tweaking and fine-tuning to get it to that point. But here again, you can increase that speed if you want. As you see it moving faster now. And then of course, here it runs stop. Turn that off, and you can see the quality of the finish, which is, in my opinion, a very good surface finish, for what we're doing here. You can make that better by simply slowing it down. I went back pretty fast, so it put some marks on it. But good chips, as you can see over here. Good quality chips. Other than that, I'm pretty satisfied. But let me show you something else here. Here you have, let me shrink this down some. There we go. Here, let's go through the modes. The first mode is like I just showed you, typical feed. Your second mode is manual move. So you're basically working it manually. And then the next mode is distance. You can set, in this mode, you can set it to go a certain distance in either direction, and it'll go exactly that distance, and it'll stop. The next one is going to be your auto threading feature, and then for that you just simply press set to enter that mode, and then it's going to ask you to set the thread type. In this case it's going to be inches, so you just click set again, and then set the thread pitch. Here it says TPI is 6. I want to change that TPI to 10 in my case, and there you go. Now it's set for 10. As far as the diameter, well, that's dependent on what you're cutting. It can be 3/8 10, it can be 3/4 10, whatever you want. And then your next one is to set the thread length. That's how far you want it to travel. You set that, and then you hit it start again. Set again. And then it says start cutting mode, manual confirm. This is if you want to start manually, you tell it to start now, you press yes. And then the start return mode is manual, you tell it when to come back, yes. And then auto run delay time is, I have it for 1 second, but the auto run delay is if previously when it was set to manual, you can also set it to auto, to where it's going to run in both directions automatically. It's going to finish a run, it's going to stop, and it's going to pause however many seconds you tell it to here, and then it'll go back to its other location. And then it says set the thread direction, whether you want a right hand or left hand thread. In our case it's going to be right, and press set again. And now it says long press set to start the automatic threading cycle, and you just press long set, hold it, hear it beep, it says save settings, enter threading starting spindle. You heard the machine wind up, confirm feed, and all you got to do at that point is just hit run, and it's going to start cutting your threads. Now I'm going to go ahead and kill that and reverse the camera. Now with that being said, we'll go back into the office, and here again, overall I think it was worth it. I mean, yeah, I had a lot of adjustments to do to it, things that I had to tweak and modify, and then I had that fuse issue that, well, it puzzled me for a little while there, but I did get it figured out. It's still a process, and it will be for a while, simply because I don't have much time to play with it. But for the money, would I buy this again? If you have enough common sense to have the ability to correctly set up the things and fine-tune the adjustments and clean the grease off the machine and stuff like that, now I'd say yeah, sure, I'd buy it. It's worth it. It serves its purpose. It comes in handy, and I think as of right now, I think it's pretty useful. But at any rate, I will do some more videos, probably a little deeper in detail, showing you more things about it. Hopefully this video helped you out quite a bit. Now, I did not buy this one off of the Vevor website. I bought this one off of eBay, and that's where I got that big discount. I think on the Vevor site they're $14.99 or $1,500, but again, I got that one for $13.50. And you can check eBay now and see how much they are. But what I like about it is the fact that it is long enough to, and more than long enough to hold an entire cue. It does core until I blew the damn fuse, and that's been corrected. But here again, I think that was more me than it was the machine. I'll attempt it again later on and see if I can't adjust my settings and get a better core. When it did core, it cored great. Now, after the adjustments, it is a very accurate machine and very rigid. So that's my take on it. You know, if I hadn't, would I have purchased this machine if I didn't know how to make these adjustments? Absolutely not. But with a little bit of common sense, I feel that the adjustments that need to be made can be made by the average person, and I think it is worth the small investment that it costs. But that's my take on it. I hope you guys enjoyed it. I hope it's a little bit informative. And look forward to some more videos soon, I believe. I'll see you soon, guys. Thanks.